Alright guys, this first one, we have a negative exponent here. To get rid of a negative exponent, we're going to put it underneath 1. So our kind of rule is basically take and put it underneath 1. And so you get 1 over 5 squared, which we can evaluate as 1 over 25. So whenever you have a negative exponent, you're just going to go ahead and flip it. If it's at the top, you're going to take it to the bottom. If it's in the bottom, you're going to take it to the top. Negative 3 to the 0 power. Anything to the 0 power is 1, always. These are really good rules you could add to your note card. Okay. Moving up. We get a to the negative first, b to the 0 power. We can plug in what we know for each of these. Okay. We already know that negative 4 to the 0 power is going to become 1. So we're just going to basically get that to be 1. And then with a negative 1 exponent, it's going to go ahead and go underneath. So the 2 is going to go to the bottom. 2 to the first power doesn't really change, so we just get basically 1/2. Okay. Alright, number 4. Just going through all these, remember wherever I see negative exponents, let's zoom in a little bit. Wherever I see negative exponents, I want to go ahead and do the opposite, or flip it into the opposite spot. So this y is going to come to the bottom, and the z is going to come to the top. So they're going to kind of almost like switch spots. The x to the 0 power is going to go to 1, so basically it doesn't really do anything. I get 3. The z is going to come upstairs, and the y is going to be downstairs. That's a 9. Doesn't look like 1 up there, but it is. Questions on 4? Number 5. Okay. Number 5, we have no negative exponents, so we don't have to do any moving up and down between the numerator and the denominator, but I do see to the 6th power here, so I'm going to distribute the 6 in. So we're going to get x to the 9th power and y to the 24th power all over. This is going to be x to the 6th power, y to the 6th power. Because we have exponents on the bottom, this becomes our quotient rule. Okay, when we divide, we're going to subtract the exponents. So 9 minus 6 is going to leave me with x to the 3rd on top. Does that make sense? Okay, subtract. 6 from 24 is going to leave me with y to the 18th power. So we subtract exponents. Okay, sorry, my hand will go out of the way. So we subtract our exponents when we're dividing. Number 6, we have a 3, and it's going to distribute to each piece. So I'm going to get 4 to the 3rd power, x. 6 times 3, when you do a power to a power, you multiply the exponents together. Do it to the bottom, that's going to be x 2 times 3 and y 9 times 3. Okay. Go ahead and take care of all those things. 4 to the 3rd power is going to be 4 times 4, which is 16. And then 16 times 4 again, it's going to be 64. This is going to be x to the 18th power over x to the 6th power and y to the 27th power. We're not quite done. I see that we can do a little subtraction here, right? The x to the 6th and the x to the 18th. We could go ahead and do a little subtraction. 6 from 18 is going to leave us with 64 x to the 12th power over y to the 27th power as my final answer. So these are all of our exponential rules. We're starting in Chapter 7. It's 1027, in case you were wondering. Thank you. Okay? Alright. Moving back up here. Number 7. Again, we have that negative exponent, so it's going to flip my whole equation. This is going to become 4 to the third power, or sorry, 4 divided by 3 to the positive fourth power. Okay? And then we can go ahead and evaluate that. Again, you can use a calculator. I'm going to use one here because 4 to the fourth power is 256 over 3 to the fourth power, which is going to give me 81. Okay. So that's the first page right there. A lot of exponential rules you guys want to know and be ready for. Flip it. Alright, number 8. For number 8, we're trying to simplify this expression. Basically, when we have fraction exponents, we're actually going to go ahead and we're going to put it into our radical. The bottom number tells me what the index is. So for this one, I'm going to get the cube root of 64, and I'm going to get the square root of 36. So what 3 equal factors multiply to give me 64? We just did this problem. It's going to be 4 times 4 times 4. And 36, we're going to look for 2 equal factors. That's going to be 6 times 6. Okay? So what we end up with is 4 plus 6, which equals 10, our final value. That makes sense? Okay. Cube root, we are looking for 3 equal factors. Now, if you look at our next one, we are looking for the 4th root of 16, and then at the end, we're going to cube it. So the first thing I got to do is I got to find my 4 equal factors that multiply into 16. Okay, anyone know what it is? 4 times 4 times 4 times 4 sounds like it might be too big. Let's try 2. 2 times 2 times 2 times 2, right? Those are 4 equal factors that would multiply to 16. So when I take the 4th root, I get 2. And then at the end, I have to raise it to the third power. 2 times 2 is 4. 4 times 2 is 8. Okay? Alright, it says classify the given polynomial as a monomial, binomial, or trinomial. Mon means 1, bi means 2, tri means 3. And then identify the degree. Okay? So that's off the page here. But we want to identify this is going to be 1, 2, 3 terms. This is a trinomial. Okay, the bottom one here is a monomial. It's all by itself. Okay, and we want to identify it by its degree. You look for the highest degree. This one has a degree of 2 plus 2. So this is going to be a degree of 4. Okay. And our next one is going to be a degree of 7. We get 2 plus 1 plus 4. It's going to have a degree of 7. Okay. 11 asked me to write the polynomial in standard form and identify the leading coefficient. So we want to put the largest exponent power in the front. So this is going to become 3x squared minus 2x plus 10. We always put the constant at the end. And my leading coefficient is right here. And I'm going to just shorthand this and just write LC for leading coefficient is that negative 3. For the bottom one, we're going to do x to the 4th minus 5x squared plus 7x plus 15 My leading coefficient is technically a 1. It's kind of hiding there in the front, but we get a leading coefficient of 1. It's the number in the very front. Okay. All right. Simplify by combining like terms. We're going to go ahead and circle or box our like terms. So negative 10, negative 13m, those are able to combine, and we can also combine these. So negative and a negative, that makes a negative 23m. Positive and a negative, we're basically subtracting, but we're going to leave it negative. 18m to the 4th. And if you can, always leave it with the highest degree first, or highest exponent. So 18m to the 4th. Okay. All right, number 13, we're adding. Again, we can just add like terms. So this is very similar. Circle our like terms. This one's boxed because they're slightly different. X and 6, that's going to become 7x to the 5th. Negative 1, positive 8, that's going to become a positive 7x, and then we just get a negative 3. Feeling good? See a lot of people focusing, that's good. Alright, flip it. 14, this one's a little bit harder because we're going to subtract first. So I basically have to distribute the negative through this trinomial here. So this is going to become a negative m to the 5th, a negative 7m to the 3rd, but then a positive 4. So I'm basically changing all the signs of the one in the back. After I do that, then I just combine like terms. So I'm going to get 5m to the 5th minus m to the 5th, which is going to become 4m to the 5th. Then I get negative 3m, or negative m to the 3rd, and negative 7m to the 3rd. That's going to become negative 8m to the 3rd. And then we're just going to add 4 at the end. Okay. Alright, the park trail is 10x plus 4x plus 2 miles long. The hiker has traveled 5x minus 1 miles. How much further to the end of the trail does he have to go? So we're basically just going to subtract. So we know the whole trail is this long. It'd be like saying the trail is 10 miles, he's hiked 2 miles. How much further does he have to go? You're just going to go ahead and subtract 8. I noticed some of you guys look really bored. Do your best to stay awake. This is the most riveting thing you've ever done, I know. Again, we have to distribute the negative here, so we get negative 5x plus 1. We get 10x squared plus 4x plus 2. Combine like terms. Now that we've distributed that negative, we're going to get 10x squared. This is going to become negative 1x plus 3. So by my calculations, it looks like he has a long way to go. 16, basically same problem. Jenny receives some money. She has spent 4x2 plus 5x plus $10. How much money does she have left? I'm actually going to not complete this problem because it's pretty much the same problem we just did. I'll just write the setup for you guys. And we're going to distribute that negative and then combine like terms. Okay. Alright, 17. Okay, this one looks scary, but it's really not that bad. Okay? What? So number 17, we're going to actually just multiply the like terms. So 1/11 and 33, if you were to multiply that, what would you get if you divided 33 by 11? Just you get 3. Okay? And then we're going to multiply the x's. So here's my x's. When you multiply